Aircraft and support equipment corrosion has been a problem since the early days of flight, and now it costs the Air Force over $5 billion annually. Today's complex aircraft and support equipment systems are constructed using many different metals and composites. This means that you need to understand what causes corrosion, how it impacts systems and equipment, and why your strict adherence to technical order requirements is critical to maintain their structural integrity and longevity. Your role is vital in preventing corrosion from literally eating away at our high-value military systems. In fact, the success of our Air Force corrosion prevention and control programs depends on you, on your performance of periodic cleaning, inspection, lubrication, and application of sealants and other materials according to technical order instructions in order to prevent and control corrosion. So, how and why you perform required corrosion prevention and control activities has a direct effect on the way corrosion impacts our ability to perform our mission. This video will give you a better understanding of how corrosion occurs, why it's important to accurately document your corrosion findings and actions, and how the use of corrosion prevention and control materials and processes authorized by technical orders can significantly reduce the cost and impact of corrosion on our crucial warfighting equipment. So what is corrosion? Simply, corrosion is the deterioration of a material, usually metal or a metal composite, caused by its chemical reaction with the surrounding environment. 4 elements must exist for any type of metallic corrosion to occur. First, there must be metal that has a tendency to corrode. This metal is referred to as the anode. Second, there must be a less corrosive conductive metal known as the cathode. Third, these metals must be structurally connected, usually by direct contact, to allow electrons to flow from the anode to the cathode. 4, the anode and cathode must be exposed to an electrolyte that provides a conductive liquid path to exchange ions between the anode and cathode and complete an electric circuit. Common electrolytes are water, soil, or acid. These 4 elements form what is known as a corrosion cell. The corrosion process cannot occur if any corrosion cell element is absent. Thus, corrosion prevention methods seek to deny the presence of at least one of these elements. There are many conditions that influence the initiation and impact of corrosion. Some of these factors are the type of material, type of electrolyte, availability of oxygen, temperature, time of exposure, stress, and other biological conditions. Aluminum is still the preferred lightweight material used in aircraft and equipment construction. Pure aluminum is very corrosion resistant, but in order to improve strength, magnesium and copper are added to form aluminum alloys. While this strengthens the material, the aluminum can act as an anode, and the alloy metals can act as cathodes. All that is needed is an electrolyte to complete a corrosion cell and initiate corrosion. Electrolytes collect easily on metal surfaces. The rate of corrosion is increased when electrolytes, usually some type of moisture, combine with dirt, engine exhaust, or acidic gases. Oxygen is also a key factor in the corrosion process. Metal surfaces corrode more rapidly when the amount of oxygen in the electrolyte increases. System engineers are responsible for designing structures and components so that corrosion can be reduced, eliminated, or controlled. They try to anticipate where corrosion cells can develop and design the structure or component to eliminate at least one element of a corrosion cell. Or they make changes to the design to reduce the potential for cells to develop if it's impossible to completely eliminate them. For example, a steel fastener or cathode in direct contact with an aluminum skin or anode can create a corrosion cell that causes the aluminum to corrode if an electrolyte is present. So the engineer might specify an aluminum fastener if it will provide the required strength. If an aluminum fastener isn't strong enough, the engineer might require that a steel fastener be installed using primer or a sealant to avoid direct contact between the fastener and the aluminum skin. The sealant or primer electrically isolates the anode from the cathode and also helps keep moisture from becoming a corrosion cell electrolyte. Eliminating any structural connection between anode and cathode and blocking the formation of an electrolyte removes 2 of the 4 elements that constitute a corrosion cell. Maintenance supervisors and technicians can also eliminate or delay the development of corrosion cells. Closely following tech data will ensure that the correct materials and processes are used. On the other hand, simply forgetting to apply the correct sealant to a fastener before installing it can cause significant corrosion problems if an electrolyte or direct connection between materials is introduced and the corrosion cell is formed. High temperatures can cause serious corrosion of aircraft and support equipment. Hot temperatures accelerate corrosion initiation in vulnerable materials and also promote mold and bacterial growth. These small biological organisms that tend to grow in closed areas that remain damp for long periods of time can induce corrosion that remains undetected. Many mechanical and environmental conditions influence the onset and propagation of corrosion in military equipment. Areas that are subject to constant mechanical stress are extremely vulnerable to corrosion. This includes stress caused during manufacturing as well as during equipment operations. Likewise, since equipment is stationed in or deployed to almost every part of the world, it is exposed to a variety of corrosive environments. Familiarity with local and deployment area conditions are important for understanding each area's environmental impact on corrosion. One of the most corrosive environments is found in coastal regions with high humidity and salt concentrations. Dissolved salt forms an especially strong electrolyte. Industrial areas can contain pollutants that are released into the atmosphere and create harsh corrosive environments. Geographic areas with sand, dust, or volcanic ash present another unique corrosion problem. When these fine particles are deposited on surfaces or penetrate sealed internal areas, they can promote corrosion by blocking drain holes and increasing temperatures. Corrosion detection is everyone's responsibility. This responsibility goes beyond the established requirements for aircraft, component, and equipment inspections and reporting found in technical order or TO requirements and local inspection procedural documents. The responsibility also includes visual observation and reporting of any indication of existing corrosion or conditions that could cause corrosion. A clear description of observed conditions that indicate actual, suspected, or potential corrosion should be documented using standard discrepancy reporting procedures. When you identify a corrosion problem, how do you find out what the limits are on the observed damage? Start by looking in the applicable tech data. TO 1-1-691 covers general aircraft corrosion, including theory, preventative maintenance, corrosion treatment, and authorized cleaners and solvents. TO 1-1-689 covers avionics-related corrosion information. TO 35-1-3 covers corrosion-related information for support equipment. Additionally, the specific aircraft-23 or equivalent corrosion-related technical data is available for each type of aircraft and most types of equipment. When you enter a corrosion discrepancy on the aircraft or equipment forms, you must ensure that a detailed description of the discrepancy is written. This should include the name of the component, its location on the aircraft or equipment, and a clear description of the damage, including the degree of corrosion. There are 3 degrees of corrosion that are identified in TO 1-1-691: light, moderate, and severe. When you enter corrosion discrepancies in the applicable maintenance data collection system forms, it is imperative to use accurate work unit and HAL malfunction codes. Accurate, factual inputs allow accurate tracking of recurring problems, aid in permanent correction of corrosion discrepancies over the life of the equipment, and add reliable data to databases used for cost of corrosion studies. You will confront many types of corrosion during inspection and maintenance. The cause and impact of a particular type of corrosion will depend on the material, manufacturing and assembly methods, preventative measures during manufacturing and operation, operational environment, operating conditions and stresses, and effective preventative and corrective treatments of corrosion you find during maintenance and inspection. Pitting corrosion is the most common type of corrosion found on aluminum alloys. Here you see an example of light corrosion which shows minor pitting and discoloration. The first indication of pitting is a gray or white deposit. When the deposit is cleared away, tiny holes or pits are evident. Moderate corrosion may show evidence of flaking and scaling, along with some paint blisters. Severe corrosion includes many of the same characteristics seen in moderate corrosion, but intergranular corrosion and exfoliation are also present. Intergranular corrosion may appear as small cracks along the grain boundaries of a metal. Exfoliation is a form of intergranular corrosion caused when corrosion in the grain boundaries builds up and causes blistering and flaking at the metal's surface. If you observe other types of corrosion that you are unfamiliar with, refer to TO 1-1-691, TO 1-1-689, TO 35-1-3, the aircraft-specific -23, or other equivalent corrosion-related tech data to identify the type of corrosion. Each series of aircraft and type of equipment has specific areas that are susceptible to corrosion, but those areas may vary between aircraft series and equipment types. TO 1-1-691 and Aircraft and Equipment Inspection Cards define very specific areas, components, and parts that are susceptible to corrosion and should be inspected. Fasteners are found in almost every area on aircraft and equipment and are often problem areas. These areas are subject to heavy operational loads, moisture intrusion, and possible corrosion from the surrounding substrate skin. Spot welded assemblies are highly susceptible to corrosion because of water entrapment caused by holes and gaps created between the parts. Engine exhaust areas are often blistered by heat. Gun and missile exhaust surfaces are also blasted away by high-velocity gases and shell casings, causing damage to the protective finish. In addition, these areas can become potential water traps. Wheel wells and landing gear assemblies are extremely susceptible to corrosion because of exposure to the environment. These areas are also vulnerable to water entrapment. Open flight stations and aircraft cargo bays are vulnerable to the environment during aircrew entry and cargo loading. Engine inlet and aircraft frontal areas, such as wing leading edge surfaces, are constantly exposed to rain, dirt, dust, and other abrasive elements. Battery compartments are also vulnerable to corrosion, despite special paint coatings applied in those areas. Leakage of battery electrolytes or fumes from an overheated battery can cause accelerated corrosion. Galleys, lavatories, and crew relief areas are extremely corrosive areas because of food spillage and urine spray. The latrine and crew areas should be inspected and cleaned after each flight. As a member of the maintenance workforce, you can have a significant impact on corrosion prevention and control. Early detection of corrosion is a key factor in combating corrosion. The sooner you identify a potential corrosion problem, the easier and less costly it will be to repair. And use of proper maintenance practices is another key factor in combating corrosion. So you should be aware of the following do's and don'ts. Improper use of tools has caused a vast number of corrosion mishaps. Don't use items such as screwdrivers and knives for sealant removal. Use non-metallic sealant removal tools. Circuit breaker assemblies need to be cleaned regularly to prevent dust and dirt from building up. Moisture also has a tendency to accumulate in these areas and has been the cause of electrical short circuits and failures. Don't use graphite marking media, such as lead pencils, for marking on any metal surface. That can promote accelerated corrosion. Chalk or greased china markers are the preferred method. A lot of damage is caused by cargo pallets and tie-down chains used to secure the pallets. Take the time to report these types of equipment damage to avoid major corrosion problems. Proper storage racks help prevent unnecessary damage to panels, doors, and other components that are removed during maintenance. If racks are not available in your work area, ask your supervisor about getting some. Aircraft and equipment surfaces are particularly vulnerable to both natural and man-made environments. After surface pretreatment, organic coatings consisting of a primer and top coat are applied to protect these metallic surfaces from corrosive environments. and the ability of these environments to initiate and propagate corrosion on material surfaces. Since these coatings are the first line of defense against such corrosion, you should frequently inspect aircraft and equipment to identify any damage to their coatings. You should document the type and extent of such damage so authorized repairs can be made and/or touch-up materials applied. Preventing corrosion is much more cost-effective than treating or repairing materials damaged by corrosion. It is important to properly wash aircraft and equipment at specified intervals and frequently spot clean to remove corrosion-causing contaminants and to provide clean surfaces for accurate corrosion inspections. Cleaning also improves the overall appearance of the aircraft or equipment. The cleaning schedule should be tailored to the environment in which the aircraft and equipment are operating. TO 1-1-691, TO 35-1-3, and some item-specific TOs have mandatory wash intervals that are based on the environment in which the aircraft or equipment is being operated. Wash intervals are typically shorter in severely corrosive environments. Before starting a wash, check the applicable technical data for preparation and cleaning requirements. You must cover all areas that should not be exposed to cleaners and solvents. Be sure to use specified cleaners, and if an automatic dispenser is used, set the dispenser to the proper mixture ratio. Avoid spraying cleaners into areas containing exposed connectors or sealed bearings, or where drainage is inadequate. Rinsing cleaned areas is as important as scrubbing them, since cleaners can severely damage coatings if not thoroughly removed. When you have completed the wash and rinse process, remove all of the protective covering and check areas where water can be entrapped. Likewise, you should ensure all drain holes are free of obstructions. It's very important that you remove as much water as possible from water traps, so you may have to open or remove panels or use forced air to dry these areas. After you complete the cleaning process, you must reapply lubricants and grease to required components. This is important to prevent material wear and moisture accumulation and to fill air spaces in order to restore the basic barrier against corrosion. Be sure to remove any excess grease around fittings or excess lubrication on hinge assemblies to prevent the buildup of dirt, moisture, and debris. Always refer to the applicable technical data to be sure you haven't missed anything in this process. Performing frequent surface wipe-downs are just as important as performing scheduled cleaning, and can actually cut down on the time you spend washing. It is critical that you use only TO-authorized cleaners for spot cleaning. Currently authorized spot cleaners are available in convenient pump or aerosol spray containers. Using unauthorized cleaners can promote accelerated corrosion rates on metal surfaces and cause hydrogen embrittlement on high-strength steel alloys. There have been many documented cases of critical landing gear components breaking from hydrogen embrittlement after being cleaned with unauthorized cleaners. Using authorized sealants provides another important method of corrosion prevention and control. When properly applied to joint areas, they prevent extensive corrosion from intrusion by moisture from condensation, rain, and salt water, and by dust, dirt, and fluids. It is critical that you choose the correct sealant for a specific area or situation, and that you apply it correctly. Thoroughly prepare the surface before applying the new sealant. Correctly mix the components to assure proper curing and adhesion. And always check shelf life date on the label to be sure the product life has not expired. Not doing so can result in an application of a sealant that fails or does not provide an effective barrier to moisture and contaminant intrusion. Corrosion preventative compounds, or CPCs, are also used to protect aircraft and equipment components and parts by preventing corrosive materials from contacting bare metal surfaces. Many of these compounds also displace water, including seawater, prevent other contaminants from adhering to bare metal surfaces, and provide lubrication as well as corrosion protection. Corrosion-prone areas or surfaces where paint has been damaged should be routinely protected by CPCs until a more permanent treatment, such as paint touch-up or sealant, can be applied. There are many types of CPCs used specifically on aircraft components and equipment. Consult TO 1-1-691, TO 1-1-689, TO 35-1-3, or the aircraft or equipment-specific TOs for use and application of CPCs. The information covered in this program is designed to provide a better understanding of your important role in preventing corrosion. Keep your eyes open for indications of impending or actual corrosion on the aircraft and equipment that you help to maintain. Take the time to accurately describe, document, and report corrosion discrepancies as soon as you discover them. Use only technical order authorized materials and processes to perform your corrosion prevention and control activities. If every maintainer follows these simple recommendations, we can help reduce the cost and impact of corrosion on all of our vital warfighting equipment.